part of the algorithm when translating an ER diagram to tables. You can always simplify the primary key as long as you use a candidate key, or in other words, use the unique constraint in SQL. Then you can just add on another primary key column that's a small integer. That way, when making foreign keys from some other table, your foreign key doesn't have to be like 4 or 5 columns wide. So an optimization that will make your life easier and will also improve your grade, because we will be looking for that kind of thing. Okay, any questions on that? All right, let's do, yeah.
So in MySQL, you can have 2 columns that are unique, and they both have to be, or the combination has to be. Is that?
In MySQL, the combination of 2 columns has to be unique.
Sorry, so in MySQL, if you have B and A constraint as unique, then
yes,
the combination has to be unique. Like
right. If you put B and A into a uniqueness constraint, then the combination of the 2 is what has to be unique. Okay. So we are moving on to kind of like, this is like roughly the halfway point of the semester, and we're going to move on to writing SQL queries in software so that we can use a database as part of a larger software system instead of just doing them on the command line or in relational algebra and things like that. So first I want to just show you the LMS project that you'll eventually build. This is Visual Studio. Since my project type is it's an MVC web server project. So almost all of you hopefully are familiar with Visual Studio and C#. So there are console applications, forms applications, various different kinds of projects you can make. This is a web server project. So when I press run, and I already did, it automatically started up a web browser. So a web server project, when you run it, will automatically, the result is a web server, so it automatically opens a browser to the right address and port. This is just localhost, so it's running on my laptop. You'll eventually publish your web server to a Linux machine where you can access it over the internet. So here's the very simple, not flashy welcome page. So we have, since I zoomed in, the register and login there got collapsed into a little menu thing. So there's all kinds of CSS and Bootstrap stuff provided for you. I don't expect you to be like web experts and make this stuff all work. But so we can like go to home, about. I'll leave this up to you. If you want to put some interesting information in here, you can. That's not really important though. So we can log in or register. So I will log in with one of these UIDs that the browser has automatically remembered for me. So remember, UID is one of the attributes on a user. Okay, so it logged me in. I have a GPA. That means this is a student. So when you log in, you don't have to say, I'm logging in as a student or an administrator or whatever. It knows that based on your UID. And then the home page for a student is your classes. So this is a list of all the classes this student has been in. Some of them have not been graded. This is all just kind of like temporary data in here. So I can go and click on like 2420 and then it takes me to all of the assignments for that class. Okay. And if it's been graded, if I've submitted something, then it has a score. So all this stuff, it's just pulling this from the LMS database. And your job is basically you write several functions. I will give you the signatures of those functions and everything, just skeleton code. Parameters will be passed into those functions, and you write an SQL query that finds the appropriate data and returns it to the web server in such a way that it can render it like this. Straightforward. So the goal is I want to minimize the amount of actual web software you have to write because this is a databases class, so that's the focus. Let me go back. Let me go to a different class here. So I'll click on, this was a databases class. So here's lab 1. This is actually just copied from an older version of a databases class like this one. So remember, so someone tell me, what is the contents of an assignment in your database? So HTML, kind of more basic. What is the SQL type of that column in your table, in your assignments table? Yeah, varchar 8192. So it's just text. HTML is just text, so we can put HTML in there, and the web browser magically renders it properly. Okay, so that's, again, that's not anything your database needs to be concerned with. It's just save the text, give it to the web browser, and it'll do whatever it needs to do with it. Okay, I can click on catalog, and then that just shows broken down by department all of the classes. And I've only got a few in here. So I have art, CS, and physics. If I click on, say, digital photography, it shows me the information about that class and gives me, since I'm a student, gives me the option to enroll. So if I click that button, you can imagine what your code would do is add an entry to the enrollments table for this student for that class. Okay. Let me log out. And I will log in now as different user. So this is an instructor now. So I can go click on algorithms and data structures. These are the assignments. I have some submissions to each of those assignments. So if I click on like the lab 1 submissions, it tells me the student, the current score that I gave them, and I can view their submission. So this person said the answer is pi on their submission. Again, just text. I can go to students, see all the students enrolled in my class, the grade, assignment categories. Okay, so I can make a new category like, I don't know, test category, give it a weight, and so on. So all the interface is provided for you. And you basically, when I click on any of these links or click on any of these buttons, the web server that Visual Studio supports is basically going to execute some function that you will fill in with the appropriate queries. Okay. Let me go back to the student and just kind of give you a better idea of what you're going to be interfacing with. So I'm going to go back to that assignment we were looking at. Okay, so how did your web server, or how did your part of the web server, your code, how did it know to pull up this particular HTML? So here's the URL. And I know you can't read that, so I'm going to copy it into something with a larger font. Okay, so let's just kind of break down this URL. That's how a web server knows what you're asking for. So this first part, localhost with a port slash student slash assignment. Okay, so that's just kind of like where are we going within the web server. And the rest of this stuff, subject equals CS, num equals 6016, season equals summer, year equals 2018, category equals labs, assignment name equals, and then the rest of that stuff is just encoded HTML. The percent 20 means a space. Or, yeah, I think those are spaces or something like that. Okay, so given all of this information here, CS 6016, summer 2018, labs, lab 1, that's enough information for you to go and find exactly one specific assignment out of the entire university LMS. So your job would basically be take that information and do something like select contents from, you'll have like tons of joins here, like classes, join, categories, etc. And you'll have a big filter where you have all of this stuff, and then you get the appropriate contents. So how do you get that info out of the URL? You actually don't really even need to do anything. So let me show you the part of the code that you'll be implementing. So here is common controller.cs. So you're implementing various controllers in the model view controller architecture. Here's get assignment contents. It just automatically passes in subject, number, season, year, category, name. So in here is where you will actually do something like select whatever and then return something. Okay, so what do you actually return? And we'll get much more into the details of this. This is just kind of a preview. So this function is returning an iAction result. And all of those functions will return that. Basically, what it's looking for is you can return JSON where, so your particular database is going to have potentially different types in all of the columns than my particular database is, right? You might treat something as a short or a long or a uint or something where I treat it as a signed byte or I don't know, whatever. There are differences. And furthermore, there's some of these controllers want complex information, like not just one big long string of HTML. Some of them want essentially like a table, like student name, student grade, student name, student grade. So you'll be returning like an array of complex objects, and instead of returning exact known C# types, because I don't know exactly how your tables will be designed, and everyone's will be different. So you return JSON, where you can just kind of say something like, given an exact interface where I'm looking for something like UID, and then you can put in, select result.uid plus, and then more JSON stuff. But the point is, by using JSON, it essentially creates a universal interface where as long as you give it the right name for all of the fields, then my web server can deal with it. Okay? And turns out C# has lots of awesome built-in things. You're not actually going to be manually even constructing JSON like this. You can basically do an SQL query and then just say, now convert that to JSON, renaming this type, or renaming this column to this name. And lots and lots of automatic stuff just happens for you. Okay, so just kind of a very quick sneak peek of the kind of second half of the semester, what we're eventually going to be building up towards. Any questions on that? Yep.
I have one based on the students table in this case. If you're just going to be returning the UID as a string, would it be better to consider the UID as an int and then maybe parse the U away and bring it back whenever you're trying to display it?
So would it be better to make the UID an int in the tables? There are arguments for and against that. The arguments against it are you're going to have to add and remove use in a bunch of places. The argument for it is that it's probably the primary key, and that makes it a better key since it's an integer type. Yep. So actually, great point. That's one of the other things I wanted to show. Let me log out, and now instead of logging in, I'm going to click register. So this is making a new account. I can pick the role I want. So anyone can actually just make an administrator account and go like delete classes or something. But it lets you select the department. So this already is, this little drop down is the result of a query that you will run and return a list of all the departments. So you can pick one, put your name in, put your date of birth in, and pick a password, and then click register. And notice there's no spot for me to say what my UID is, obviously. You don't pick your UID, the system picks it for you. So if it's a string, that makes it a little trickier. You have to kind of implement your own auto increment on strings, which is not too bad. But that's really the only place where using a string kind of gets trickier, is just in this one spot. Okay. Any other questions? Okay. I'm going to pause for another minute and give everyone over here another chance to move, because I doubt you can see anything from way over there. So let's just take a 1 minute break. The only table that should really have a primary key with more than one column is a table that came from a many-to-many relationship. So in our example, it should pretty much just be students and enrolled. Even those, if you want, you could do the same trick and just make the two things unique and then add an additional primary key. But making a complex primary key in these two tables is fine. Okay, so now that we're moving on, today we're going to talk about C# a bit, and I know most of you have experience with it, so it'll be a very quick reminder of basically the important things that we'll need. So first of all, why are we using C# instead of anything? You know, you could argue Python, you could argue Java, you could argue C++. Well, one answer is just why not? So don't be one of those people that's like an evangelist for any particular language. Just pick the language that's right for the job, or if you have to use a certain language, then just use it to the best of your ability. The better answer is that C# is excellent for the kind of stuff we need for web servers and integrating with databases. So C# has this thing called LINQ, Language Integrated Query, which basically, by the end of the project, so I said you'll be doing something like this, writing SQL statements. You'll actually be writing LINQ statements, which is part of the C# syntax. So it's not actually SQL, but it looks like SQL. So it's kind of like SQL built into C#. And the point is, it's not specific to SQL. You can use LINQ on just C# objects. So it's like you can write a query that has like from and join and where and stuff like that. But you can just do it on like a C# dictionary or hash map. And that also decouples it specifically from SQL. And you could easily then go apply it to some other database query language backend. And all of your queries are the same, and they all just work. Okay. Excellent support for web servers, including JavaScript. But again, you don't have to worry about that too much, other than you're implementing the backend parts. But it just, because of that, it makes your job super easy and specific to databases. Whereas you might have to actually write some CSS or HTML or JavaScript if we were trying to do this some other way. Okay. So, very quick whirlwind recap of C# things that you'll need to remember. So C# has namespaces, which it borrows from C++. And basically, it's a way of getting around the fact that you sometimes want two classes with the same name, but they have very different meanings. So if I want to make my own class called vector and math already had it, then I'd just kind of be out of luck. There has to be some way around this, and C#'s way is namespaces. So basically, it puts an additional identifier in front of your class name. So like math.vector or collections.vector or mine.vector, whatever. And then coupled with that is the using keyword, which is also borrowed from C++. So if I don't always want to have to specify math.vector, I can say using math. And then it will automatically search that for any type that I try to use. Okay. And this is going to be quick, so just stop me. Any questions? I know some of you have not even seen C#, but probably most of you have. Okay. So I'll just go over some of the things that will be very relevant for us. A lot of this stuff you'll just kind of have to Google or do your own little research. C# has this iDisposable interface, which basically means it has a dispose method or like a cleanup or undo method. And basically the idea is you have some object where you might get it into some sort of partial or inconsistent state, and you don't want to leave it in that state. So if you try to do something, you expect it to work, but something might go wrong, like the file doesn't exist or the connection was closed. Then you could put try, do your stuff, and then finally o.dispose. So finally, and notice I don't even have catch here. Finally is part of the try block. But basically it means always do this thing at the end, even if an exception was thrown and caught, or if no exception was thrown. It'll always do that last. Okay. But there's a shortcut for this that also uses the using keyword, unfortunately. So if using appears in a function instead of at the top of your file, then it means this. So it's a shortcut for creating an iDisposable object, and then you put a scope, curly braces, do whatever code you need, and then dispose will automatically be called on that disposable object. Just a shortcut for try final. Okay. So this applies to us because opening an SQL connection or running an SQL query is something that could easily just not work like in the middle of all the code you're running. You might lose your connection or whatever. Okay. Yeah, so as an example, so using MySQL connection, whatever, equals something, and then you just do all your stuff in there. Okay. C# has the enumerable interface, which is kind of like Java's iterator or iterable or something like that. But basically it means it enables the for each loop. So enumerable is on just tons and tons of collections and objects in C#. It just means you can loop through some everything in some kind of collection. It applies to us heavily because database queries in C# in that link that I talked about, language integrated query, heavily tied to IEnumerable. You make a query, the result is an IEnumerable. So it's basically like an enumeration of the rows that were returned. Okay, and then C# and Visual Studio specific. When you type // above a function, it automatically gives you a little auto comment XML block, and this is what enables like the autocomplete or the code archaeology stuff in Visual Studio. And they will be required on any function you write in your code. Okay, so just a little bit on Visual Studio project or program organization. So it basically comes down to a solution and projects. So solution is like the whole program. So my web server was a solution. And within my web server, let me stop it so we can see the code view. Within my LMS solution, I have an LMS project. So this one turns out is only broken down into one project, but then it's divided into just folders to sort of better separate the code. Data, models, services, views. You could also break it down into projects. So you might, for a game, for example, the whole game is the solution, and you might have a UI project and a network project. Each of those can contain directories and classes and things like that. Okay, and then references are kind of like the import analogy in Java. So using is not import. Using is just look for something with this name. Import in Java means actually import some code from somewhere else. C# does that with references, and it's not actually even specified in the code. It's specified in Visual Studio. Technically, it's specified in the project file. So think of that kind of like a makefile. Anyone taken 3505 yet, so you know about makefiles? It's a metadata file that says this class needs access to this DLL. Okay? So you won't actually even write anything like, import the MySQL library or pound include the MySQL library. You do that all just kind of through the interface in Visual Studio. Okay, finally, and again, very, very brief recap of C#. You'll probably need to kind of do your own Googling whenever you get stuck on something. So MySQL in C#, and we're going to talk about the basic, more simple way of doing it first before we talk about link. So we're going to actually just use the MySQL library, which is different from link. We'll get to that later. But basically what we need is some way of connecting to a server. So just like on the command line, you type MySQL -u -h -p, stuff like that. Just put all that information into a string. And I've asked most of you this before. What are your thoughts on the software engineering design of this piece of code? Password is in plain text in the source code. Yes, so if this was an open source project and you published it to GitHub or something, then everyone in the world knows the database password. Okay, so don't do that, obviously. Also, don't make your password hello. We'll talk more about passwords later on, and specifically how to store passwords. So we're making an LMS. Everything in the ER diagram so far, there's one big thing missing that you might be wondering is, what about a password? And I showed that when I logged in on the web browser. I had a password. So where's the password stored in the database? None of your tables have a password column. We'll actually do that in a slightly different way because passwords are obviously critical and sensitive and special. Okay, and then, so instead of hard-coding your password, just do something that prompts the user for it at runtime. Or if you're making a web server, notice I logged into my web server, I typed in my user password. I did not have to type in a database password in order for it to do all those queries to my tables. The web server itself just knows the database password. But the web server should not store that password in plain text. It should put it in like an encrypted file or key somewhere saved on that machine. Okay, so what are your thoughts on this, software engineering of this? This is a little better. But I'll still say it's not perfect. Yeah, exactly. So, what if somebody is watching you? Console.readline is just going to show whatever text you're typing. So Instead, you could do something like this. So there is, unfortunately, with Readline, there's no way to say, turn off the characters that they're typing. You can do it when you're reading one key at a time. So we just put it into a loop, read a whole bunch of keys. With that true parameter there means hide the input. And then as soon as they press enter, then you say, all right, that's the password, and we'll use that. Now the password is nowhere, it's never displayed anywhere. The only place it ever exists is in memory in the machine. Granted, it is unencrypted in that machine's memory, but that's relatively safe aside from things like a meltdown attack where some other process can gain access to your process's memory. That's a different issue, though. So there are better ways. This is kind of ugly, actually, for reading a password. There are better ways to do this. In the web browser, you saw when I typed my password and just put dots in. You don't have to do anything about that. You just say, here's an HTML field that has characters replaced with dots. And I actually just provide all of that for you. But the point is, think about passwords. You have to think about this stuff. It doesn't just automatically come out magically in the code. Okay, and then, so once we have our connection string, including the password, which was read dynamically, we use this using, because a MySQL connection is disposable, and we just pass in the connection string, open the connection, and then do whatever. So then we can start building up select commands or insert commands and executing them. So so after opening the connection inside the using block, we basically just put in the exact SQL text of the query. So something like select author from titles, join, whatever, and just put that into this property of a MySQL command. So it's no magic here to make the SQL statement work in C#. It's exactly SQL syntax. Then you execute the command using a MySQL data reader, which is also disposable. So you put that in another using block, and then that will go to the server. Server will run the select, and it will return information in some format. It's standard format that you don't really need to worry about, but the MySQL library knows how to interpret that format, and it basically builds an enumeration of the rows and columns that were returned. So that looks kind of just something like this. And notice this is not using a for each loop. The link version of doing this will use a for each loop, so we'll get to that. But for now, I just do while reader.read. So reader was that object that I created here and executed a query. Reader.read will advance it to the next row. Then I can do things like index into the reader using the index operator with either a name or an actual index. So if you know the index of the column based on your query, then I can just say, give me the one at column 1. Or if you know the name, then give me the one with that name. Okay, so I know most of you have seen this before, and so we'll wrap up the quick review right now, and this will be a good time to take a 5-minute break. Little demo. We're basically just going to play around with SQL select and insert from C#. So here's just a simple program with main. It's a console application. I've made my connection string. So there's a server, there's the database I want to use, UID, and then I say connection string equals read password. For the purposes of this demo, I've actually just made read password return my password because I'm going to be running this a bunch and I don't want to just have to type it and slow things down. So bad engineering there, but as far as it looks, this is fine. Assume read password actually prompts for the password on the keyboard. Okay, so part 1, we're just going to do some simple select queries. So I've already kind of got the infrastructure set up. So using MySQL connection with the connection string, open it, make a command, and then fill in the text with the SQL command, and then make a MySQL data reader after executing that command. Okay. So we're using Sandbox, which has like the super basic LMS tables in it, like students enrolled in courses. So let's just do select star from students natural join enrolled. Okay. And then we'll execute that. Semicolon, someone said. Turns out you don't actually need it. It kind of automatically appends it for you. And then we can just do while reader.read. So that advances it to the next row. And then we can do, so let's just kind of, I don't know, print some stuff. Console.writeLine reader at, so I know there's a column in there called sname, student name. And then I'll print also CID. Okay, something like that. So, you know, nothing too magical here. We get the results of the select. This is just showing how we do this in C#. Let me make this just a little more readable. Okay. So alternatively, we could also do column 1. I believe that is the sname column, but you know, probably better if you know the name of the column, use the name of the column. But one of the points is these queries are unlikely to change. So you know, if you're writing some piece of software that accesses a database over and over again, and if you have figured out that that's the right column, then that's probably fine. But still not as good as just using the name. And all of this is still nowhere near as good as link, which we'll see later. Okay. So that's just kind of a basic select. Insert commands are a little different in that you don't use a reader on them. You usually don't really care about the result. So you just, they're called a non-query. It works the same way though. You make a command and you just put in the command text. So insert into whatever, and then just command.execute non-query, and that's it. It's done and you move on. So it does return something though. It will return the number of rows affected. Question?
So here you show how SQL returns warnings.
So yeah, so if we want to get warnings, we can basically access a property of the command after the command has been executed. Then we can go look at the warnings. Errors will also, so command.execute non-query will throw an exception if something goes wrong. Okay. So let's think about a little use case here. And in fact, this is homework 5. Let's say you have a giant text file full of chess games in PGN format. And you want to write a C# program that just reads that text file and uploads all of those games to the database. Okay? So seems straightforward. The issue here is every game is one just standalone block of text, and it says which event it was from and the date of that event and everything like that. The next game, even if it's at the same event, will just repeat that information. So it's not like a hierarchical, say like here's the event, here's a bunch of games in the event. So as you're reading through this list of text, you will encounter the same event many times. So you could, yes, in C#, you could make like a dictionary and read the whole text file first into memory and build up all of the unique events and the games within. But it has to be able to work with another PGN file. So say you run it again the next day with a different PGN file, it might also have some of the same events or players. So you can't really rely on knowing what is in the database when you're offline. So you have to be able to either insert or not insert a new event if it's already there. Same goes for player name. So you might be tempted to put all of your logic into C#. So this sounds like a super simple if statement. If the event doesn't exist, add the event, right? And that's the way you're trained to think. You can do an if statement in your sleep. So you might run the select command and then do something like if reader does not have any rows, then run the insert command. Problem with this is, so let's just look at what happens here. So you've got two machines now. You have your laptop and you have the server. Your laptop is going to run a select command, which goes to the server, it does some things, it responds. Then your laptop does a little bit of logic, so that if not has rows is C# logic. Then you run an insert command. And all of this stuff takes time. And in fact, an insert, so obviously the select is blocking. If we're waiting for the result of the select to switch an if statement, obviously we have to wait. But even the insert itself is blocking. So if I run and execute non-query, that will actually block your program until the server has done the query and responded with the number of rows affected. So all of this stuff is just kind of slowing things down. And you have, say, 10,000 games in memory that you need to upload to the database. These dashed lines here are going to be by far the biggest bottleneck in that. So what we can do, though, is SQL can do a lot of logic. So you have to try to think, what parts of my logic that I'm so naturally inclined to put into C# can I put into SQL? And SQL can do this, and then we get rid of an entire round trip to the server for every single insertion. So let's go up to part 2, where we're going to do some inserts. And which means I'm going to change the database to chess2. I'm just using chess2 because I don't want to mess with the other one. I'm treating that one as read-only. This is kind of like a copy of the other one. Okay, so part 2. What we want to do is, just as an example, let's say we're inserting an event called test, and the site is nowhere, and the date is today. Okay. First, let me go to chess2 in the actual database and make sure that that event doesn't already exist. So I'm going to delete from events where name equals test. Okay, so it was actually already in there because I was playing around with it earlier. So let's do it the naive way first, the basic way where logic is in C#. And I've left the command kind of incomplete. So what we're going to do is first select, see if there is an event with this name and this date, because those are the two things that make up the key in an event. Turns out we don't really care about the site. And then we're going to check if it has any rows. If not, we'll add the new event. But I've left this command incomplete because there is a little bit of interesting, there is an interesting issue here. So select star from events where name equals test and date equals 2019-02-25. There's a problem with this, though. This is not a valid SQL query because this is a string and this is a string. So we have to actually put the quotes in and you have to escape them since the whole thing is inside of a C# string. Okay. With me? All right. And then we can execute the reader. And then basically we would do something like if reader.hasRows, then we can just return. Okay. Otherwise, we can do another command. Command text equals insert into events. I want to insert name, site, date. Values, and then we will do test, comma. We'll just say like nowhere and today's date. I got one of my backslashes in the wrong place. Okay, does that look right? Missing a closing parentheses. So it's actually kind of tricky when you're trying to get SQL queries to work inside of C# because Visual Studio doesn't know about the SQL syntax, and it's not going to tell me about things like that missing closing parentheses. Okay, and then we would just do cmd.execute non-query. Okay. So let's try that. Okay, so it just says done. Let's select star from events where name equals test. Okay, so there it is, it worked. And I left off, notice I just said in my values I wanted to insert, I only specified these three because the other one is auto increment. So it gave me a new event with a new ID. Okay, now let's just run it again. It says done, we're good. Okay, because of this. I said, you know, I did the select first. If it has any rows, I return. Otherwise, I do the insert. Okay, but we want to get rid of that double round trip in order to do this. So turns out we don't even really need to check. So I'll just comment all of that stuff out. Let's just try to do the insert. And what happens now is I get a duplicate key error because the combination of name and date has to be unique, so it's throwing an error. That's why I had that logic to check, so that I don't end up with my program crashing in the event that there are multiple games from the same event, which there definitely will be. Okay, so here's one option. We'll try to execute it. We'll catch an exception if anything goes wrong. And we'll just, I don't know, print the message of that exception. Okay, so now it's not crashing and everything's fine, except you know, it's going to print a whole bunch of things in reality. You have to remember the actual file that you're reading from and inserting these events from is going to be very large. So, but fine, you know, it works. It's just a matter of like best practices. And so maybe you would actually just kind of comment that out if you don't want anything to happen here. But what if something actually did go wrong? It's not just a duplicate key problem. What if it's like your query was malformed? Then you would actually want that to be a real exception and do something about it. The biggest problem with this is try and catch is very expensive. If you're doing this and you expect it to happen a lot, you're basically just accepting that your program is going to be slow. So here's kind of what we just did. And the general rule of thumb is exceptions are for exceptional events. So if you know that there are going to be lots of cases where there's a duplicate entry, that should not be an exception in C#. That should be handled in some other way. Not only because this is kind of masking what is a real error. An exception should be a real error. What if a real error does happen? Then you've kind of got confused what happens in the catch block. Is it an error or not? Okay. So the other option that we've already kind of seen is just do an insert ignore, which converts errors to warnings in MySQL. So option 2 is run an insert ignore command and then profit. Yes, you actually do profit because it saves you time in the execution of your program. So here's the diagram now. I run an insert ignore. The server processes it, responds. But even with insert ignore, there is still a blocking delay here. The C# code will actually wait for it to finish. So as we're kind of going through this, let me just keep this all updated with what we're doing. So instead of try catch, I will simply do insert ignore and then execute the query.
So will blocking freeze our application? Is that why we got one?
Exactly. So blocking means it waits. Your application, on this statement right here, your application will not proceed until the server responds. Okay, so that's all well and good, but what if we actually do want to know whether or not it was a new event or not, whether it was duplicate or not? We had that information by catching an exception. We could have said this was not a new event, otherwise it was. So what we can do is the execute non-query returns the number of rows affected. So int rows equals. And then we can just do if rows greater than 0, something like, print or increment a counter or whatever. So we still have logic in C# now, and there's really no getting around that. If what I want is to count something in C#, but it's now the logic is not done through exceptional control flow. Okay, any questions? So a lot of this is, we started with something that was correct. We did a select, checked the number of rows, then did an insert. It's fine, it works. But a lot of this is just engineering practices. So it comes down to all this stuff we've been trying to do is move as much logic into SQL as possible and away from C#. And why? Well, basically, we've already kind of seen why. The answer is we want to avoid going to the server as many times as possible. So the diagrams I had here are very out of scale with respect to this time axis. It would actually look something more like this, where the amount of time just to send the message to the server and get the message back is orders of magnitude longer than the amount of time it takes to execute the query. unless it's some super complicated query. But it's going to be something like 100 times slower than just doing the query itself. So the very first attempt we had 2 round trips to the server, 200 milliseconds, versus getting it down to just 1, which is still bad, but 2 times better. Okay. So, and then the trade-off is, well, by pushing logic to SQL, doesn't that make the queries more expensive? Yes, but SQL is very good at parsing and running queries, as good as any optimizing C# compiler is. So get rid of the trips to the server as much as possible and make your SQL commands as complex as they need to be to move all of that logic to the server. Okay. So one more thing you might be wondering. This blocking insert, right? An insert is usually you can think of an insert as like fire and forget. Like just do it and then move on, I don't care. If you don't care how many rows were affected by the insert, why should we wait here for the server to say, okay, here's how many rows were affected? And you're right, maybe you don't need to wait. So the options are, do any of the tricks you already know. There are asynchronous MySQL libraries where you can say, like, execute query async. The MySQL library we're using has async versions, but it's only in name. They're not actually asynchronous. It's really annoying. There is a different library that is actually asynchronous. But all that stuff is just kind of syntactic sugar, and you can do it yourself. You can just make a new thread, run the insert command, and then just don't join the thread. If you don't care when it's done, then just start it and move on. And then you can start doing useful work while the query is running. So this is like if you really expect that query to be, take a fair amount of time, and you don't care about the result. Okay, and then one final, can anyone think of any other optimizations we could do here in terms of reducing the number of queries? Remember, you have a giant text file on your computer. You read that text file into memory, into some like array of games and events or something like that.
Keep a set of the events that you have actually tried to insert into the server, and just ignore any line that includes.
Okay, so keep a set of events so that for every event you try to insert, you're actually only going to try once. And then you still do need to do insert ignore because you might be dealing with another file at another time. Yes, okay. So you still, though, are going to be, for every single game, every game is unique. You're going to be doing a whole bunch of inserts on those games.
Can you just insert many games at one time?
Yes.
To the chain of inserts?
So we've seen insert does not have to be just one column. You can just put a comma, parentheses, and more rows. So there's a trade-off, though. You don't want to do an insert that's like a megabyte of text or something. Usually, you want to kind of trim it down to something like 10 inserts per command or something like that. You'd have to actually profile it to figure out the right number. But if you do that, then suddenly you have 10 times fewer trips to the server. Okay. So this example we've seen, let me clean this up. This example we saw where we first had, do an insert command or a select command, check the result of the select, then conditionally do an insert. And then we trimmed it down to just this, insert ignore, and then we can count the number of rows returned if we care. That was an example of reducing trips to the server, but it's a pretty simple one. So let's look at another one, part 3. So this one is going to be changing a student's score on an assignment. So I have commented out here a pseudo actual query from an LMS. So the problem here is, let me just explain what we're imagining is happening here. So you have an LMS with tons of students with tons of scores. And let's say that somebody screwed up and like all of the scores were potentially wrong that they submitted to Canvas. And they don't want to have to go through the web interface and click hundreds of times. So they've somehow produced a big text file of the fixed scores. And so those scores are in some kind of file that maybe looks like this. This is sort of like PGN format, where it's just text describing a whole bunch of things. So for this student, for this assignment, in this category, in class, and whatever, the new score is 97. And so on. So tons and tons of these. But what we're doing is we will allow the student to keep the higher score. So if we messed up, we will give them the higher score since it was our fault. So this is their correct score, but if the messed up score was higher, then we want to keep that one. So we have a condition there, basically. Which score is higher, and then if the new one is higher, then we update the entry in the database. Okay. So this would be kind of like the select command you would do to find the student and submission for that specific entry in that text file. But just to make the actual examples simpler to think about, I just kind of hard-coded an assignment ID and a student ID in the submissions table. Okay, so we are getting the score for a particular submission to a particular assignment for one student. I execute the query, and then I do something like, if there was no submission in the first place, well, then something was wrong with the text file, so I return. Otherwise, I advance the reader because I know there's one row. And I get the old score. So if I'm actually requiring it to be a certain type instead of just relying on toString, I actually do have to parse it. So I'm saying I know that column 0 will be an int. So reader, give me an int out of that column. And then I have C# logic. If new score greater than old score, then I'm going to run an update command. But first, I have to do all this stuff. I have to close the old reader. You can't have two commands open at the same time. And I would do something like update submissions, set score equals new score, where same condition for that particular submission. So you can write an if statement in your sleep, and you'll be tempted to just do it this way because that's the way you know how to do it. Turns out, we can just get rid of like all of this stuff. Comment all of that out. So how do we push logic to MySQL instead of doing it in C#? Update submissions, set score equals new score, where assignment equals 3 and student equals UID, if the new score is higher than the old score. Any ideas?
Can we just make it another part of our where?
Yes, exactly. So let me just, on a new line, add to this command where score less than new score. So that's only going to do an update if all of the condition is met. So the condition is find the assignment ID, find the UID, and make sure that the current score in that row is less than the new score. Then we will update the score. So, it's not a direct translation. There's no if here. There's no like then, things like that. So you have to think about, how do I move C# logic to SQL? Now what we've done is we have one query instead of two queries. Twice as fast.
Did you already declare the where clause? You were just using and instead.
You're right, we need and. Thank you. That's just an additional rule to my where clause. Okay. Any questions? Yeah.
So why is it called execute non-true when that is a true?
So the term query is kind of overloaded. It's a non-query because it's an update, not a select. Basically, non-query means I don't want rows back. I just want to change something, insert something, delete something, update something. Okay. We're out of time for today, so we'll see you next time.